Hey everyone, ready to dive deep into some seriously cool tech?
Ah,
Buckle up, because today we're talking about high-speed oscilloscopes.
the oscilloscopes.
Yeah, those instruments that let us see like super fast electrical signals.
The kind that zip around in everything.
Exactly.
Yeah.
Everything. From smartphones to even our brains.
Yeah, our brains.
It's wild. So for this deep dive, we're going back in time a bit.
Back to 2003.
Yeah, 2003, a pivotal year for oscilloscopes. They were going through some major transformations, kind of like a tech puberty.
Well, our source material is actually an article from that year.
Oh, cool.
Yeah, from April 2003. It's by William L. Weaver, and it was published in Scientific Computing and Instrumentation magazine.
Nice. So what does this Weaver guy had to say?
Well, he was talking about these new oscilloscopes as like instruments on steroids.
Instruments on steroids. Okay, I'm intrigued.
He wasn't kidding either. Back then, he was comparing these souped-up oscilloscopes to something called scientific CCD cameras.
CCD cameras.
Yeah, they were used to capture images too, but they were more common in other fields like astronomy. And Weaver, he jokingly called them egocentric.
Egocentric cameras. Okay, now I'm really curious. Why'd he call them that?
Well, unlike oscilloscopes, which he called well-mannered, these CCD cameras were kind of like standalone units.
So they were hard to, like, connect to other systems.
Exactly. They were difficult to integrate into larger setups.
So why was that a big deal? I mean, it sounds kind of technical.
It was. Think about it. Scientists were trying to study events that were happening super fast.
Like, how fast are we talking?
We're talking billions of a second.
Wow. Okay, so to really understand what was going on, they needed more than just one instrument, right?
Right. They needed to synchronize data from multiple instruments.
Got it. So you couldn't just use the oscilloscope in isolation. You needed to be able to connect it with other tools to get the whole picture.
Exactly. And that ability to connect, to integrate, that's where those steroids come in.
Okay, now we're getting to the good stuff. So what kind of steroids are we talking about?
Well, Weaver goes on to describe three big players in the oscilloscope game at the time.
Hit me with those names.
Tektronix, Agilent, and LaCroix.
All right, all big names. So let's start with Agilent. What did they have cooking?
They had this model, the Infinium 54850.
Infinium 54850.
And this thing was a beast.
Like a monster truck of oscilloscopes.
Kind of. It was basically a computer with a super fast signal capture device attached.
Whoa, serious tech.
Yeah. It had a Pentium III processor, Windows XP, a massive hard drive.
No way. For back then, that was cutting edge.
It really was, and it marked a major shift.
A shift.
Yeah, oscilloscopes were becoming less about just measuring and more about actually analyzing.
I see. They were evolving.
Becoming like powerful computing platforms.
And what about features? Did this Agilent model have any cool tricks up its sleeve?
Oh, yeah. It had this thing called Megazooom.
Megazooom. That
Yeah.
sounds intense.
It was. This feature could capture a ridiculous amount of data in a single recording.
How much are we talking here?
32 million data points.
32 million. That's insane.
I know, right? Can you imagine trying to make sense of all that data by hand?
It'd be like finding a needle in a haystack.
More like a needle in a stack of needles.
So Megazoom, it let scientists zoom in on even the tiniest detail.
Exactly. Details of these super fast events.
Like glitches or anomalies that they might have missed before.
Exactly. It was a total game changer.
Okay. Agilent was clearly bringing the heat. What about Tektronix? Did they have something to compete?
They did. Their TDS 6000 series, it had similar processing power to the Agilent.
Okay, so also packing a punch. But did it have anything unique?
Oh, yeah. This one had a really cool innovation.
Lay it on me.
They called it digital phosphor technology.
Digital phosphor. Okay, that sounds like something out of Star Trek.
It kind of was. It was all about mimicking the afterglow effect you'd see on those old school analog oscilloscopes.
The classic green trace on a black screen.
Exactly. But Tektronix added a twist.
What kind of twist?
Color.
Whoa, color.
Yeah, they used different colors to represent different signal frequencies.
So instead of just a fading green line, you'd have a rainbow of information.
Exactly. It was like taking a black and white photo and suddenly seeing it in full color.
Wow, I bet that made a huge difference for researchers.
Oh, absolutely.
But how?
Well, imagine you're looking at a signal with all sorts of different frequencies mixed together.
Okay, I'm picturing it.
With the old black and white display, it would be super hard to see those individual frequencies.
Yeah, they'd all just blend together.
Right, but with color coding, suddenly you could see which frequencies were present.
And how they were changing over time.
You got it.
That's incredible.
Yeah.
So Agilent had Megazoom, Tektronix had digital phosphor. What about LaCroix? What was their big innovation?
They had the Wavemaster 8600A.
The Wavemaster, okay.
And this one, it was pushing the limits with something called extreme technology.
Extreme. Sounds powerful. What did it do?
It used super fast AD converters. That's analog to digital, by the way.
Thanks for clarifying.
No problem. And it also had a direct pipeline to the CPU's memory.
Okay, so it was all about speed.
Oh, yeah. It achieved incredible data throughput.
So it could handle massive amounts of information in real time.
Exactly. It was revolutionary.
Okay, I'm getting a sense that all three of these companies were in a serious tech race back then.
Oh, absolutely. They were constantly pushing the boundaries of what was possible.
So we've got Agilent with Megazooom, Tektronix with digital phosphor, and LaCroix with Extreme. Did any of them have any other tricks up their sleeves?
Well, actually, LaCroix had one more thing.
Oh.
They offered a software customization package that was way ahead of its time.
Customization.
Yeah, users could write their own analysis routines and interfaces.
Whoa. So they could tailor the oscilloscope to their specific needs.
Exactly. No more clunky batch commands or anything like that. It was seamless integration.
That's amazing. So LaCroix was really emphasizing flexibility and user control.
They were. It was a huge selling point for researchers who wanted to really push the limits of what they could do with an oscilloscope.
So all three of these companies, Agilent, Tektronix, and LaCroix, they were all making major strides in oscilloscope technology.
They really were. It was a golden age for innovation in the field.
And it's incredible to think that this is all happening back in 2003.
I know, right?
It makes you wonder how far things have come since then.
It really does. But before we get too ahead of ourselves,
Right.
let's take a step back and think about the bigger picture.
Okay, sounds good. Let's zoom out for a second.
It's wild to think that Weaver was writing about this stuff almost 20 years ago.
Yeah, like it's ancient history in the tech world, right?
Totally. But it makes you wonder just how much further things have come since then.
Oh, for sure. I mean, we've talked about these fancy features.
Megazoom, digital phosphor, extreme.
Yeah. But, like, what does it all mean? Why should anyone care about these super fast signal captures?
That's a great question. Think about it. Pretty much everything around us relies on electrical signals in some way, right?
Yeah, I guess so.
Your smartphone, your car, even your nervous system, it's all electrical signals.
And those signals are moving super fast.
Crazy fast. So if you want to understand how these things work...
Like how to design better technology.
Exactly. You need to be able to actually see those signals.
Okay, that makes sense.
Yep.
So high-speed oscilloscopes are like the ultimate tool for that.
Think of them as like the detective tools of the electrical world.
I like that. So they let scientists zoom in on these super fast events and really see what's going on.
Capture those tiny details that you wouldn't be able to see otherwise.
So in Weaver's article, he focused a lot on electronics and research.
Yeah, but it feels like the applications go way beyond that.
Oh,
right?
totally. I mean, I bet these oscilloscopes are used in all sorts of fields.
Absolutely. Think about medical imaging.
Medical imaging.
Yeah. High-speed oscilloscopes are essential for things like ultrasounds, EKGs, EGs.
Whoa,
Yeah,
really?
yeah.
So they help doctors see what's happening inside the body.
Exactly. They can visualize the electrical activity in the heart, the brain, other organs.
That's incredible. And what about things like telecommunications? I bet they play a role there too, right?
Huge role. In telecommunications, they're crucial for analyzing all those super fast data streams that are flying through fiber optic cables and wireless networks.
Wow. So they help keep our internet running smoothly.
Pretty much. They help optimize performance, troubleshoot problems, ensure reliability.
So basically, they're the unsung heroes of our connected world.
I'd say so. And to think, all of this was back in 2003.
It's mind-blowing when you think about how much we rely on this technology.
And how advanced it's become since then.
So if those oscilloscopes were already so powerful back then, what can they do today? What are the limits?
That's the exciting part. The possibilities are pretty much endless.
Okay, I'm ready to have my mind blown. Give me some examples.
Well, for example, imagine using high-speed oscilloscopes to study signals from deep space.
Oh, like signals from stars and galaxies.
Exactly. It could help us unlock some of the biggest secrets of the universe.
Okay, now that's what I'm talking about. That's incredible.
Or how about mapping the electrical activity of the human brain in real time?
Okay, now we're getting really sci-fi. But seriously, would that even be possible?
It's becoming more and more possible. It could revolutionize our understanding of consciousness, thought, even emotions.
So we could literally see how our brains work.
In a way, yes. And think about the implications for things like artificial intelligence.
Oh, yeah. AI is already changing the world so fast.
High-speed oscilloscopes could help us develop and analyze even faster and more powerful AI systems.
It's like we're on the verge of some major breakthroughs in so many different fields.
And it all goes back to those instruments on steroids that Weaver was talking about back in 2003.
It's a reminder that even seemingly simple things like visualizing electrical signals can have a huge impact on our world.
Absolutely. It's all about seeing the unseen and using that knowledge to push the boundaries of what's possible.
I'm definitely feeling inspired. What about you?
Me too. It's an exciting time to be alive, that's for sure.
It's crazy to think that something as basic as seeing electrical signals can have such a huge impact on, well, everything.
It really shows you just how connected everything is.
Right. Like from the tiniest particles to the entire universe, it all comes down to energy and information.
Exactly. And oscilloscopes, they're giving us a way to see that, to understand that fundamental language of the cosmos.
It's like we have a new way of seeing the world.
A new set of eyes for the unseen.
And the crazy part is, these instruments are still evolving.
Getting more powerful all the time.
Who knows what we'll be able to see and discover in the future?
It's pretty exciting to think about.
I bet Weaver never imagined that his instruments on steroids would one day be used to explore questions about the brain, the universe, consciousness.
It just goes to show you the power of human curiosity.
Right, we're always pushing the limits, always wanting to know more.
And these tools, they're helping us do that, helping us see further and deeper than ever before.
I don't know about you, but I'm feeling super inspired right
Me
now.
too! It makes you realize that we're living in a pretty amazing time.
So as we wrap up this deep dive into the world of high-speed oscilloscopes, what's the big takeaway for our listeners?
I think the biggest takeaway is this. Never underestimate the power of a new perspective.
Ooh, I like that.
High-speed oscilloscopes, they're more than just tools.
They're like, what, keys to unlock new knowledge.
Exactly. They're enablers. They're empowering us to ask bigger and better questions.
We challenge what we think we know.
To push the limits of human understanding.
And who knows, maybe one day we'll have oscilloscopes so powerful that we can capture the signals of thought itself.
Whoa. Now, that would be truly mind-blowing.
Right. We could literally see the flow of ideas, creativity, consciousness.
Like having a microscope for the mind.
We could understand intelligence in a whole new way, maybe even communicate telepathically.
Okay, now we're getting a little carried away.
I know.
Yeah.
But it's fun to think about the possibilities.
It is. But let's bring it back to the present for a second.
Okay, back down to earth.
For all of you listeners out there, keep exploring, keep asking questions, keep pushing those limits.
You never know what incredible discoveries are waiting out there.
Couldn't have said it better myself.
Well, that's all the time we have for today's deep dive.
Thanks for joining us.
It's been a blast exploring the world of high-speed oscilloscopes with you all. Until next time.